So, in this particular lesson, we are going to start our conversation about rational expressions. And this one does have a tendency sometimes to be a little bit trickier than most because most students are not fans of fractions. But if you notice, the definition of a rational expression is the ratio of two integers p over q. Or a rational number, that's 2/3. That's what you're used to. Okay. The definition of a rational expression is a ratio of two polynomials. Now, they have some great examples down here. You have the polynomial 2x plus 5 binomial over a trinomial 4/5. Even though it's a rational number, it's considered a rational expression because it is something in fraction form. And then, of course, in the last example, you have a trinomial over a monomial, and that is okay because they're rational because they're fractions. So the word rational means fractions, excuse me. All right, so in the first two examples, we're not going to do example 3, but in the first two examples, we are going to evaluate. And if you recall what evaluate means, it just means substitute the given value and then use the order of operations to simplify that problem. So I'm going to take out every single r and replace it with 3. So that would be 3 plus 2 in the numerator, 3 squared, plus 2 times 3, plus 5 in the denominator. So my numerator is not 6, it is 5. Then I have 9 plus 6 plus 5 in the denominator, which is 20. And that does reduce to 1/4. So 1/4 would be the answer once we plugged in r equals to 3. So in our second example, the value they give us is -4. So -4 minus 2, -4 minus 3 in the numerator, and then we have -4 plus 1 and -4 plus 4. So when I simplify this, I have -6 times -7 over -3 times 0, and I end up with 42 over 0, and that means my problem is undefined because you remember you cannot divide by 0. If 0's in the numerator, that's okay. You can have 0 on top of that fraction all day long. You cannot have 0 in the denominator of your fraction. All right. Now, restrictions. The reason we have restricted values on rational expressions is because denominators cannot equal to 0. So if your denominator equals to 0, you have an undefined fraction. So what we're going to do is we're going to identify the restrictions. So it tells you exactly what to do. Set the denominator equal to 0 and solve it. Now, sometimes, like in number 4, you get g minus 2 equal to 0. That's just a basic linear equation. So g cannot equal to 2. Okay, so the restricted value is 2 because if you were to plug 2 in, that would give you 2 minus 2, and that would give you 7 over 0. So I can plug in any other number or use any other number for g in this problem except for 2, because 2 produces a 0 in my denominator. Now, my denominator this time is a quadratic, so I'm going to have to factor. So the factors for this quadratic are -4 and +2. I use one of each when I factor it because my 8 is negative, my c value is negative. So remember, -4 times 2 should give you c, and -4 plus 2 should give you the b value, which is -2, and it does. So once I set my factors equal to 0, I have my restricted values for this particular problem. So f cannot be -2, or +4. Those are my restrictions on number 5. Those are the two values that I cannot have. Now, number 6 is special because x squared plus 16 equals to 0. This is a sum of squares, and it's prime. You cannot factor it. So therefore, you have all real numbers, meaning that there are no restrictions. You can use any number that you want. And your denominator for number 6 will never equal to 0. So you can try it. Any number you want, square it, add it to 16, you're not going to get a 0. And a lot of people go, well, if I square -4, I get -16. You don't. -4 squared is +16, and that does not equal to 0. So there is no number that restricts that particular domain. In number 7, take your denominator, set it equal to 0. So your restriction is that a cannot equal to 0. All right. Now, in this particular problem, it says construct a rational expression that is undefined when x is -3 and x is +1. Well, that would come from the factor x plus 3, and this answer would have to come from x minus 1. So I can do 2 over x plus 3, x minus 1. And that is just an example where these two values would restrict my domain. It would cause my domain to become a 0. So all I did is I worked this problem backwards. I added 3, x plus 3, set it equal to 0. And I worked backwards. I subtracted 1, x minus 1, and set it equal to 0. So there are my two factors. So I'm just working the problem backwards. Your car, cars can't always go in forward. You are in drive. You have to put it in reverse sometimes. So sometimes we do have to work some problems backwards from time to time. All right, so now we're going to get into simplifying expressions. So to simplify a rational expression to lowest terms, we simplify the ratio of common factors to 1. So basically, what we need to do is we're going to factor anything and everything that can cancel or factor, and then we're going to cancel common factors. Now, for 9 and 10, they want us to identify restricted values. So we're going to do that part first. 9x minus 18 equals to 0. That gives me 9 times x minus 2 when I factor it, and x minus 2 equaling to 0. So my restriction is 2. Now, that was the identify the restricted value. So x cannot be 2 because 9 times 2 minus 18 equals to 0, and that's not possible. Your denominator cannot be 0. So when I factor the numerator, if I factor the x, I get x minus 2. If I factor the 6 out, I get x minus 2. We already have the factors of the denominator. I can cancel the two common binomial factors, x minus 2. That gives me 6 over 9, which gives me 2/3. So this is the answer for part B when I simplify the expression to lowest terms. All right, in number 10, we're going to identify the restricted value first. So I'm going to take 9x squared minus 16, set it equal to 0. I'm going to factor the conjugates because that is a difference of squares. So 3x plus 4 and 3x minus 4. I'm going to set each factor in that denominator equal to 0 to identify the restrictions for this particular fraction. So I get 3x equals to -4 and x equals to -4/3. I get 3x equals to +4 and x equals to +4/3. So my restricted values, x cannot be -4/3 or +4/3. Now, that is part A. That's listing the restrictions. Part B is to factor it. Well, we've already factored the denominator, 3x plus 4 and 3x minus 4. And we have to factor the numerator. So the common factor in the top would be 5, and 15 divided by 5 is 3, and negative 20 divided by 5 is negative 4. So I can cancel the common factors of 3x minus 4, and my final answer for part B would be 5 over 3x plus 4. That would be my final answer for number 10 with these restrictions. So part A, part B. All right. Now this particular set of problems ask us to simplify and express in lowest terms. Now, nowhere does it say that we have to list the domain restrictions. So we are just canceling at this point. We're simplifying. We are reducing these fractions. So when I look at 30 over 36, that reduces to 5 over 6. If you remember your exponent rule, you always subtract. So a to the third minus 5 gives me a to the negative 2. So I'm going to put a squared in the bottom because you can't have negative exponents. To get my b, that would be 4 minus 1, which is b to the third, so it can stay in the numerator. And that would be the simplified expression in lowest terms. Now, in part 12, they already have it factored. Hopefully, when you see those parentheses groups, you can tell that it's factored. So I'm going to start here with the two monomials. 6 over 10 reduces to 3 over 5. The c, if I take 1 minus 3, that gives me c to the negative 2. So I have c squared in the bottom with 5. So I've got my monomials out of the way. This c plus 2 will cancel with that c plus 2. And now this is the tricky part, because I have c minus 1 on the top and I have two c minus 1s on the bottom. That's what c minus 1 squared means. So you can only cancel 1 with 1. So I end up with a c minus 1 left in the denominator. And that would be my final answer. In number 13, I have two polynomials, and I'm going to have to factor each one of them first. So I'm going to factor this one first. So my common denominator would be 4x. That leaves me with 3x minus 5. So my numerator cancels to 4x and 3x minus 5. My denominator, my greatest common factor, is 8xy. So that gives me a 3x plus 5. Now, 3x plus 5 and 3x minus 5 cannot cancel because they are not exactly the same. So I look to the front. Monomial 4x over 8x does reduce. So I end up with 3x minus 5 over 2y and 3x plus 5. Now, I'm looking at 4x over 8xy. The x's will cancel. That becomes a 1. That becomes a 2. So 2y in the denominator. That's where the 2y comes from. In number 14, I need to factor the numerator. So that's 7x plus 2. And then I have to factor the denominator. So that would be x plus 3. I'm sorry, it would not. It would be x plus 2 and x minus 6. When I factor that. Now, notice I have one of each sign because 12 is negative. My c value is negative. 2 times negative 6 is negative 12, my c value. And 2 plus negative 6 is my b value. And that's what I want. So that's why I use these two factors. Now, I can cancel the x plus 2. That gives me 7 over x minus 6. Grand total, final answer. So there's a lot of stuff going on. So you have really got to be up to par with your factoring, because if not, this is going to be a huge struggle. All right, in number 15, this one cannot be simplified. Because my denominator, I cannot factor my numerator, and I cannot factor a sum of squares. You can only factor a difference of squares. So since I can't factor anything or break anything down and cancel that particular fraction, there's nothing you can do with it. So, excuse me, I'm trying to get my eraser. So there's nothing I can do with that particular problem. All right, so in number 16, I'm going to bring that numerator over here just so I have some extra space. I need factors of 2x, and then I need to pair those with factors of negative 6. So 1 times 6, or I can do 2 times 3. One of those numbers has to be negative. So when I go to set up my factors, since c is negative, I know I'm going to need 1 plus and 1 minus. So I need to set up my factors carefully. So I'm going to use 2x and x. And then I'm going to put 3 here, and I apologize. That should be a minus and here. So when I do that, I get 2x. When I multiply these two, I get negative 3x, which gives me, it does not give me the positive that I need. So we're going to switch those signs. So this should be positive 3, and that should be negative 1. So 2 times negative 1 is negative 2, and that will give me positive 3, and that does give me 1x in the middle. So my numerator factors to 2x plus 3 over x minus 1. I apologize. I'm going to start all over. I have totally messed up that problem. So we don't use 1 and 3. We have to use 2 and 3. 1 times 6 is 6, and 2 times 3 is 6. So I kind of mixed and matched my factors, but it didn't multiply up. So let's try again. So I'm going to use my 1x and 2x as my factors of ax squared. I'm going to use my 2 and my 3 as factors of 6. So minus 3 and positive 2. That's a little bit better. So that gives me 4x, and this gives me negative 3x. When you add those together, you get positive 1x, which is the number in the middle. So I apologize. I kind of messed that problem up pretty bad. So I hope you are able to go back and follow the correct steps. Now, in the denominator, I have 4 terms. So I'm going to have to do factor by grouping. So ax squared minus bx gets grouped together. And then the negative 4a plus 4b gets grouped together. So I'm going to take out an x here. So that is ax minus b. I'm going to take out a negative 4 here, and that is a minus b. I apologize, left off my 2. So that's going to give me x squared minus 4 and a minus b. Common factor is x squared from that first group. Now, I can break down the x squared into x plus 2 and x minus 2, and then I have an a minus b. So when I come up here and list all my factors, x plus 2, x minus 2, and a minus b, I can cancel the x plus 2's. So my final answer would be 2x minus 3 over x minus 2 and a minus b. That would be my final answer for that one. All right, now we need to talk about opposites because opposites will come up from time to time. And opposites are when 2 factors that are opposites, they form a ratio of negative 1. So opposites would be a minus b and b minus a. These are not conjugates. Notice that I reversed the order. In one problem, it's A minus B. The other one is B minus A. So some examples would be x minus 4 and 4 minus x, 2 minus x, and x minus 2. So those are examples of opposites. Now, if opposites just so happen to appear in fractions, they cancel and equal a negative 1. So you need to be on the lookout for opposites. They will cancel. Now, these are opposites. These are not opposites because they are not subtraction problems. And these are not opposites because the 5s are still negative and both x values are still positive. Just because they flipped the order does not make them opposites. It has to be A minus B and then B minus A. All right. Now, in this particular problem, we do have opposites. The 5s are opposites, the y's are opposites, so that reduces to a negative 1. This one cannot be simplified because I have a b plus 6 and a b minus 6. Just because they're conjugates of each other does not mean that you can cancel them. They have to either be exactly the same or they have to be opposites of each other. Conjugates do not cancel. Okay, in example number 20, we need to factor that difference of squares. So that would be 8 minus g and 8 plus g. Now those are conjugates of each other. They're not opposites. And then I'm going to factor my denominator. So I need factors of negative 24 that when I add those together gives me that negative 5 in the middle. So I'm going to end up with g minus 8 and g plus 3. Negative 8 times 3 is negative 24, C value, and negative 8 plus 3 is the B value, negative 5. Now, these two are opposites, and you can cancel them, but you have to put a negative 1 in its place. So in order to write your final answer, you're going to have negative 1 times 8 plus g over g plus 3. Now, technically, it really does not matter if you put the negative 1 with the numerator or if you were to write 8 plus g over negative 1 times g plus 3. Both of these are acceptable. The catch is that negative 1 can only appear one time. So it either goes with your numerator or you put it in the denominator. Now, I always put it in the numerator. That way I don't ever get confused. So when I cancel opposites, my negative 1 always goes in the top and it gets multiplied by whatever is left, if there is anything left. So at number 21, we're going to go ahead and we're going to factor out the common factor 4 in the numerator. So that's x minus 2. In the bottom, we're going to take out the 6, and that leaves me with 2 minus x. Now, these are opposites, so I end up with negative 1 times 4 on top of 6. So that's negative 4 over 6, which would end up being negative 2/3 as a final answer. So if you have any questions on simplifying rational expressions and or opposites, please contact me and let me know.